this clutch, so you can see this is your clutch plate. This is your clutch plate. So you have a pressure plate actually roughly somewhere around here, okay, which I didn't draw, okay. So this is your clutch plate. So when you refer to a clutch plate, okay, actually there is both side effective, So one side is what it is shown here. The other side is actually at the back of this clutch plate, which is in contact with the flywheel, So the number of pair of contact surface is always equals to 2, okay? So this is called a single disc clutch, okay? So here you have forces. These are forces, which we call them as the spring force or the axial forces. This is due to the pressure from the pressure plate. The pressure from the pressure plate, which is able to move forward or move backwards, depending on whether it engage or disengage. When the clutch engage, usually the pressure plate will push the clutch plate backward. So that means the pressure plate will come into contact with the clutch plate and push it backward so that it comes into contact with the flywheel. So this pressure is actually applied to the pedal, okay, or from the spring. So which exerts forces like this, which we can call them as normal forces. Okay. So as these normal forces, okay, is acting on the surface of the friction clutch, and when the clutch rotates, it actually produces these forces here that I have drawn in red, which we call them as the tangential force or the frictional force. So the blue lines here represents, the arrows here represents the spring force exerted by the pressure plate or the pedal when, okay, the pedal is released, especially in your manual cars. When the pedal is released, actually the spring will actually forces the pressure plate to move forward by means of what we call spring force, and we call it as the normal forces. Okay, so these normal forces, as a result of the rotation of the frictional plate, okay, it produces frictional forces like this. These are normal force. These are frictional force. So this frictional force is also called, which is also called the tangential force, multiplied by this radius here, the mean radius that I have noted here as R, okay, uppercase letter R, will give you a turning moment, okay, to the clutch, which produce a rotation, okay, which will produce a rotation to it. Okay, so we call this as the frictional force Fr. Okay, so this is another diagram showing you how the normal forces acting on the rotating clutch, the clutch plate, and then produces these tangential forces here. Okay, let me finish this. These are tangential forces and these are normal forces, and this is how they act. Okay, now these normal forces here, because of these normal forces, you have this frictional force. Okay, this frictional force here. That's how it operates. Okay, and this frictional force actually helps to grip the pressure plate, the flywheel all together. So this frictional force is very important, and we call them as the frictional, okay, force, which when you multiply it with the radius, the mean radius of the clutch, will give you a frictional torque. Okay, a frictional torque. So in order to calculate the power transmission, actually this frictional torque is very important. Okay, so I have these symbols here, all noted, which represents, okay, forces and the dimensions of the clutch. Okay, so the measurements of the clutch. Fr is the frictional force, so that is in red. Okay, W is the spring force or actual force or normal force, which is in blue. Okay, and then the coefficient of friction, that is due to the surface of the friction lining material. R is the mean radius. Based on the geometry of the diagram, you can see this is the mean radius. Outer radius, that is R1. Inner radius, that is R2. If let's say I want to find out the width of the lining material, if I want to find the width of the lining material, that means here, okay, the width here, look at the pointer, okay, this pointer here, okay, so this is the width. Sometimes if we want to find out the width, we can straight away take R1 minus R2, okay, R1 minus R2, that is the width. It can be denoted as B or the lowercase letter W. Okay, so T is the torque transmitted. So remember the definition of torque is tangential force multiplied by radius. So all rotating objects require torque. All objects that is moving in straight line require force. So since clutch is a rotating object, so it requires a torque in order for it to rotate. Okay, so torque is equals to tangential force times radius. Remember that, which we have done it in the previous course. So N is the number of pair of contact surface. As I have told you, for a single disc clutch, the number of pair of contact surface is 2. One in front here, which you can see, this surface that is in brown. The other surface is the surface that is at the back of this diagram, which is in contact with the flywheel. So for a single disc clutch, this N is always taken as 2. So let us consider P to be the power transmitted. Remember, to find power transmitted, you need to have the turning moment, that is the torque. Okay, to find the torque, you need the frictional force and the mean radius. So to find the frictional force, you need the spring force, okay, and the coefficient of friction. Okay, so this lowercase letter p here refers to the pressure exerted by the springs, that is from the pedals. Okay, so N is the speed of the shaft. So usually these are all mounted on shaft, okay, on a shaft. Okay, so that is driving and driven shaft. So N actually represents the speed of the shaft, which is in revolutions per minute or revolutions per second. So from revolutions per minute, if you want to convert to revolutions per second, you must divide this by 60. Okay, if you want to convert this to radians per second, RPFs, you must multiply by 2 pi. 2 pi, which is 1 cycle or 1 revolution. So Fr is the frictional force. Fr frictional force, that is in red. So you can find frictional force by taking the coefficient of friction of the lining material. So you have different type of materials. So all different materials will give you a different value of coefficient of friction. It depends on the surface texture of the material. So spring force, okay, is denoted as W, or which is also can be known as the normal force that is exerted by the springs, that is in blue here. Okay, so you can have mu W or mu R, but then we don't use R here because we have a lot of R's here representing the radius. So it's better for us to use the symbol W for the normal forces here or for the spring force. So therefore you have frictional force is equals to mu W. Okay, and we know that torque is tangential force. Our frictional force here is the tangential force. Now you can see, okay, these red arrows here actually is touching this red, okay, ring, red ring or red circle here. Okay, so that is why it's called tangent. Okay, tangential force. So the tangential force is actually the frictional force multiplied by the radius, the mean radius. Okay, for this case, in the for the general formula, we usually refers to R, the mean radius. Okay, let's say, for example, later on when we look into, okay, uniform pressure theory and uniform wear theory, the R will be derived. Okay, the R will be derived based on the two different cases. Okay, so R is the mean radius. Okay, so if you want to find the total torque, okay, you can multiply this by n, the lowercase letter n, that is the number of pair of contact surface. Okay, so you have this. So your FR is mu W, okay, your mean radius, and your number of pair of contact surface. This is the torque transmitted by the clutch. If you want to find the power transmitted, you must have this value here. Okay. Now, torque transmitted by this clutch, okay. So these are the spring force that is acting on the frictional lining. Okay, so all these we have defined. Okay, so this is the area of the entry ring. If let's say, for example, you want to learn about the proving formulas, okay, or the derivation of the formula, okay, so you have to learn from this. But for our case, we don't need, okay, to learn about the derivation of the torque transmitted formula by all the two different cases. So the first case is the uniform pressure theory. I will just go through this, okay. The main thing we have to do is to remember the main formula for this theory. Okay, I will just simply go through like this. If you've got time, you can refer to this, or if anything else, you can leave your comments, or you can actually text me, okay, if you have any questions. Okay, if you have anything, or if you want to learn how this goes about, okay, you can always text me, yeah? Note that when a friction surface is new in case of, let's say, for example, if you buy a new car, every part of the car is new. So the clutch is also new. So in that case, okay, the clutch we usually consider as referring to this uniform pressure theory, because we assume that, okay, the uniform pressure distribution, okay, over the entire contact surface, because the surface, okay, suffers no wearings, no wears, okay, no rubbing, okay, at the first time. So that's why the surface here, all the entire surface of the frictional lining material is of uniform thickness, the entire of it. So the pressure distribution on top, of this surface or on both surfaces is the same at any point that is on the friction lining material. Now this pressure will wear off. Okay, this pressure will wear most rapidly where the sliding velocity is maximum, and this will reduce the pressure between the friction surface. So if the friction surface wears off, it's just like your eraser, okay? When you use a pencil, you usually use an eraser to erase off any mistakes or anything wrong, right? So after a period of time, you found that your erasers, okay, surface is becoming irregular. That means a lot of regular shape because of constant rubbing, wearing. Okay, so if, for example, when you refer to a clutch plate, it happens. Okay, it happens also. Okay, so what happened is certain parts of the friction surface, okay, or the friction lining will be wears off. So once a surface wears off, the pressure distributed the pressure distribution will not be uniform, will not be the same anymore after a period of time. Usually it's after a period of time. This wearing in process continues until the product of pressure and volume is constant over the entire surface. Okay? So after this, the wear will be uniform. Okay, so we consider as uniform wear after that. Okay, so these are the proving formulas which you don't need. Okay, so the most important part is these two here, the final, okay, the final part of the formulas. So if you want to learn all these proving formulas, okay, we usually use integration applications. So you have to, of course, know integrations. But since you are engineering students, this has no problem for you. So the torque transmitted formula for a uniform pressure theory usually is given by this. Okay, so for uniform pressure theory, that means a new clutch. You can use this formula to calculate the torque. Okay, 2 pi mu, which is the coefficient of friction, P, which is the pressure, R1, which is the radius, okay, the outer radius, because you take this minus this. So your R1 has to be greater than your R2. So therefore, your R1 has to be the outer radius, the maximum radius, and your R2 to be the minimum radius, that means the inner radius. Okay, now these formulas can be proven out by following my steps from the previous page of my slide. Okay, then when you arrive to this, you can substitute your R1 and R2 into the equation to get this formula. So to further simplify this formula, okay, what you can do is you can take your pressure here to be force over area. This force is the normal force that is acting on the surface of the friction lining or the clutch. So this is the area, this is the area. Pi R1 square minus R2 square. This is the area. That means this blue color shaded in blue section here, the whole thing. Okay, so it is pi R1 square minus R2 square. You can substitute this into this to get to a more how to say, established formula. So torque is equal to 2 over 3 mu W inner radius, outer radius, inner radius, and this is the number of pair of contact surface, which you can put at the earlier of the equation also as well. Okay, so this is a constant when you refers to a single disk. So remember, pressure distribution will be uniform over the entire surface. So that's why pressure equals to force over area. So for uniform wear theory, where this pressure distribution no longer uniform, that means after this has been used for a number of time or a period of time, then the pressure distribution will not be uniform. Then you cannot use this formula where pressure equals to force over area. Okay, because the pressure distribution here is not the same anymore. Okay, but then this first case here is about uniform pressure theory. The next case is about uniform wear theory. So for uniform pressure theory, what you need to do is remember this, the pressure formula, and the complete torque formula for uniform pressure distribution or uniform pressure theory. Okay, that's all for this. Hope you like it, yeah, and hope you understand. If you like, please put thumbs up. Yeah, thumbs up. Elvin, you didn't record. No, so not Elvin. Defu, you didn't record.